What's going on, everyone? Welcome back. Patrick here, and moving on to the next video, the next concept, we're going to talk about limits at infinity. And not just in this video, over the next couple of videos, going to be going over a bunch of examples dealing with these kinds of limits. And in this video, I'm going to jump straight into an example where we have to find these limits over here given this function, f of x, which is drawn in blue. But before we get into the example, I actually want to make a quick note. I've mentioned this before about how limits at infinity are different than infinite limits. So you may see both expressions come up in your course. And I've mentioned this before, but infinite limits, which we've actually already covered, remember, infinite limits take the form where we have the limit as x approaches some kind of number, a, of a function. And that's going to equal plus or minus infinity. So that's the form that infinite limits take. Okay? And infinite limits are basically these a values, if this ever happens, they end up being vertical asymptotes. And notice in this example that I've written out, I actually have a couple of infinite limits. Actually, limits 1 to 4 are infinite limits. Notice they're in the format limit as x approaches a number of f of x. And actually, these are going to end up equaling plus or minus infinity, as we'll see. So 1 to 4 are infinite limits, and infinite limits deal with vertical asymptotes. But what we're going to be focusing on in the next few videos is not infinite limits, but limits at infinity. And limits at infinity take this kind of format, where we're going to have the limit as x approaches plus or minus infinity of f of x, and that's going to equal a number. So it's like the infinity and the number have been switched around. So with infinite limits, the number's here, the plus or minus infinity is there. Limits at infinity, the infinity symbol is here, and then the number is here. Okay, and limits at infinity, they end up giving us horizontal asymptotes. We're going to be talking about this more. But just wanted to make that distinction, because sometimes students can get confused seeing limits at infinity or infinite limits, right? The words are very similar, but they are different. These here are infinite limits. 5 and 6 here are limits at infinity. And what we're going to be focusing on in the next few videos, again, it's these kind of limits, limits at infinity. Okay, so we got this function, f of x here. The function is in blue. Notice that I drew out the asymptotes with dotted lines. Now, I want to make a point that sometimes you're going to get graphs where these dotted lines aren't going to be there. You're going to have to sort of eyeball them. For this example, just to keep things simple, where we don't have to eyeball stuff, I actually put the locations of the dotted lines of the asymptotes. But again, those might not always be there, and you're going to have to look yourself on a graph and see where that x value is, or maybe that y value is, and make your own dotted lines. So let's go through each of these limits here. So starting with 1, we got the limit as x approaches -1. What's that going to equal? Well, as we approach -1, notice when we approach this -1, this x value -1 from both sides, the y values are going towards negative infinity. So as we approach -1 from the negative side, it's going towards negative infinity. As we approach -1 from the positive side, it's going towards negative infinity. So you got to look, if they're just asking as x approaches -1, not a one-sided limit like we have in 2 and 3. Notice we got this minus and positive there. You have to look from both sides. And because it's approaching negative infinity from both sides, this limit is equal to negative infinity. Number 2, the limit as x approaches 2 from the negative side. Notice as we're approaching this x value of 2 from the negative side, the y values are going towards negative infinity. So this is going to be negative infinity. Limit as x approaches 2 from the positive side. Notice the y values are going towards positive infinity. So what's the limit as x approaches 2 of f of x? Well, notice they're approaching different y values from both sides. And because they're approaching different y values, negative infinity and positive infinity, this limit here does not exist. So notice it's different than this limit where they were both from both sides approaching negative infinity. Here, from the negative side, it's going towards negative infinity. Here, from the positive side, it's going towards positive infinity. So that overall limit there does not exist. Right? So those are the infinite limits. And notice that because we got these values here, these values, those a values, like I mentioned, are the vertical asymptotes. Right? So infinite limits, remember, they deal with vertical asymptotes. Okay, let's do 5 and 6. And 5 and 6 are limits at infinity, because notice we're taking the limit as x approaches positive infinity and as it approaches negative infinity. So what's it going to be as we approach positive infinity? Well, from this graph we could tell as we approach positive infinity, as we go that way, the y values are going to approach the y value of 2. That's going to be a horizontal asymptote there. So this here is going to be 2. And notice that we could approach 2 from the bottom or from the top, from below or from above. So if possible, sometimes, especially when you're going to start curve sketching, you want to write down where we're approaching this 2 from. So notice we're approaching the 2 from above in this case. Right, we're going towards the 2 from above, but we could also be approaching a certain y value from below. And then the limit as x approaches negative infinity, this one's kind of unique. Notice that this curve, or this wave rather, is kind of oscillating. So the waves are going from big to small. The waves are getting smaller and smaller as we go towards negative infinity. And so they're getting smaller and smaller. So notice that those y values are approaching 0. And they're not approaching from above or below. That's always going to be fluctuating, right? It's going to just keep fluctuating. But the waves are getting smaller and smaller. They're oscillating towards 0. So the y values are approaching 0. So they don't always have to approach from above or below. They could approach from both if you get something like that. But nevertheless, the y values are getting closer and closer and closer to 0 as x goes towards negative infinity. So these are the limits at infinity, and notice that those are the 2 horizontal asymptotes. Right? We have a horizontal asymptote here of y is equal to 2, and then a horizontal asymptote of here of y is equal to 0. And that's going to answer number 7. So the equations of the asymptotes, so the vertical asymptotes are what? -1, x equals -1, and then x is equal to 2. Remember, x equals a number. That's how we state a vertical line. And then the horizontal asymptotes are what? Y is equal to 2, and then y is equal to 0. And sometimes you want to be a little more specific here. So this y equals 2, that's happening when x goes towards positive infinity. This y equals 0 is happening as x goes towards negative infinity. So vertical asymptotes are always going to be stated x equals something. Horizontal asymptotes are going to be stated y equals something, right? And again, horizontal asymptotes, limits at infinity. Vertical asymptotes, infinite limits.